You read 2.4.
Suppose the driver in this example now slams on the brakes, stopping the car in 4 seconds. Find the acceleration, the distance the car travels while braking, assuming the acceleration is constant, and the average velocity.
Now, this 2.4 is a continuation of the previous question. 2.4 here is a continuation of this question here. Now, this question here, finally, they have attained a velocity of 8.75. Is it 8 point? No, this is the average velocity here, 17.5. Okay, so finally, after at this position here, the velocity is 17.5. Okay, now from here onwards, you step on the brake. Okay, from the previous question, when you have attained a velocity of 17.5 meter per second, you step on the brake. Okay, so they asked, the car now stop in 4 seconds. What is the acceleration? Okay, so now if you don't know what to do, then we try to list out everything that we know, right? Okay, the first thing that we know is the initial velocity is 17.5. Ayo, why I put the meter per second again? Sometimes I make mistake like that. So when I go through, then I see. Okay, now the initial velocity is 17.5 at the when we continue from here. The final velocity from here is actually the initial velocity for the second part of the journey. Okay or not? Now this for the first problem, the final velocity is 17.5. So if we continue from here, that means the initial for the next stage, for the next part of the journey, the initial velocity is 17.5. So it is here, 17.5. Okay. Then finally, when they put on the brake, slam on the brake, and the car stop. Car stop means the final velocity is 0. The final velocity is 0. And how much is the time taken? It is given that the time taken is 4 seconds. And they want us to find the acceleration. So if you look at all the physical quantities that are listed out here, and you look back at the three given equations, which equation can we use to solve this problem? If you look at all the quantities here given, V1, V0, V, A, and T. So which of these three has all the physical quantities that is given? The first one, second one, or the third one?
Uh, Third one.
Third one. Okay. Let's see here. This equation has V, V, A, and T. Got delta X or not? I mean, given the
Oh,
question.
first one, first one.
First one. Because the second one and the third one has delta X. And what we have listed here, no delta X. So I know, we must make use of the first equation. To make use of the first equation, I just copy down the first equation and substitute everything inside.
Okay.
Substitute everything inside. And when you move the 17.5 over to the other side, it becomes a negative value. So negative value means deceleration. Okay, finally we found out the deceleration is negative. Deceleration is 4.38. But if they ask for the acceleration, so you just tell them acceleration is negative 4.38.
Okay.
Acceleration is negative 3.48. But if you are talking about deceleration, then the deceleration is 4.38 without the negative sign, because D means negative already, so you don't have to mention, right? The last one, I mean second part, the distance the car traveled while braking, assuming the acceleration is constant, right? Okay, distance involve the delta x. Distance involve the delta
The
x.
delta x.
So we can either use which of this equation? Uh, both also has delta x. This one got delta
Mm-hmm.
x. This one also got delta x. So you can use either one of them. But which one is simpler? Not too many variables involved. So I prefer to use the second one, the bottom, the one at the bottom. Okay, so actually you can use uh, either one of them, right? Because now all the physical quantities is known, right? So we want to find delta x here, okay? The distance the car traveled while braking, okay? So we want to find delta x. And the equation that has delta x is v square equals to v naught square plus 2ax. V naught is the final velocity. When you slam the brake, finally it will come to a rest. So the final velocity is 0. Initial velocity is 17.5. The deceleration or the negative acceleration we have found out. So you put
Okay.
everything into this equation and you solve this equation. Answer is 35 seconds. Any question?
No.
No, no, then the last part again, they ask us to find the average velocity. Now, it will be easier for us to use the half, half the final velocity plus initial velocity. Now, this will be the easier way, right? Of course, you can also use what I've said earlier, displacement divided by time, right? The total displacement divided by the total time taken. But I prefer this one. I prefer this. Easier. Any questions so far?